Have you ever listened to a foreign language and thought that all the words ran together? For instance, the sentence, "Where are the silences between words?" is an example that there are no consistent word boundary cues in fluent speech. So how do we learn language if there are no consistent word boundaries? As we are more exposed to a language, we learn that there is a structural pattern to that language and can then more clearly segment words. This ability to find the structural patterns in language is known as statistical learning. Past research points to statistical learning as being an important mechanism for language acquisition. The first statistical learning task was established by Safran, Aslan, and Newport in 1996. Safran et al. Found that 8-month-old infants were able to segment words based solely on transitional probabilities of syllables. So this is the probability of syllables co-occurring. Transitional probabilities are higher within words than between words. Take the words pretty baby. Prit and T are more likely to co-occur than T and bay because pretty could be followed by many words, such as pretty girl and pretty rainbow. Now, before we go into the details about the methods of the study, let's go over some definitions about learning. Throughout this video, I'm going to talk about implicit and explicit learning. Implicit learning is learning without awareness. For instance, learning language. Explicit learning is learning with awareness or intention. For instance, learning how to read. For our study, we wanted to determine whether auditory and visual statistical learning are correlated using tasks that measure both implicit and explicit learning. For our task, participants listened to a 6-minute continuous speech stream. The speech stream was made up of 4 novel trisyllabic words, and they were combined pseudo-randomly with the restriction that the same word could not occur twice in a row. During the familiarization phase, the participants passively listened to the speech stream while they were coloring. For the test phase, we used Batterk and colleagues' statistical learning tasks. These tasks test both implicit and explicit learning. The first task that participants completed was the rating task, which is an implicit learning task. They would hear one trisyllabic word at a time and be tasked with rating it on a scale of 1 to 4 on how familiar a word sounded according to the language they just heard. They would hear all 4 words, 4 part words, and 4 non-words. Part words are words which consist of the last syllable of a word and the first 2 of another. Non-words are words made up of syllables that would not have co-occurred together in the language. If participants rated words higher than part words and non-words, that meant that they were able to learn the language. In addition to this task, we also used the traditional measure of statistical learning, the 2-alternative forced choice task. Participants heard a word and a non-word or part word foil. They had to choose which word they thought came from the language. There were 16 trials, and after each trial, a subjective confidence questionnaire, known as the Remember No procedure, was used to test graded differences between participants' explicit learning. Participants were instructed to give a confidence rating for their choice after each 2-alternative forced choice. There were 3 options. If they indicated remember, it meant they were confident in their answer. If they chose familiar, it meant that they had a vague remembrance of the word. And if they chose guess, it meant that they had no confidence in their answer. To measure implicit learning, we used a target detection task. There were 36 trials, and for each trial, the 4 words from the language were repeated pseudo-randomly 4 times. Each syllable acted as a target 3 times. Participants were tasked with pressing a button every time they heard the target syllable. This task allowed us to determine whether participants were faster at reacting to the final syllable of each word, which would tell us that they were able to predict the final syllable. For the visual task, we used a serial reaction time task. 4 circles were arranged horizontally on the computer screen, and participants were tasked with responding to the target stimulus, a cartoon rabbit, which appeared in one of 4 circles. There were 8 blocks with 40 trials each, and every even-numbered block had the repeating pattern sequence. For the pattern sequence blocks, participants had to respond to an 8-item sequence, which repeated 5 times. Participants weren't told that there was a pattern. reaction time, and accuracy were assessed to determine whether participants were able to learn the sequence. After the task was completed, participants were then asked some follow-up questions to test their explicit learning of the pattern sequence. The questionnaire included items such as, did you notice anything special about the task? And did you notice any irregularity in the way the stimulus was moving across the screen? After this task, participants completed a pattern completion task. This tested whether participants were able to remember the pattern sequence. The first rabbit appeared in the first circle of the pattern. After the first trial, participants would then see 4 blank circles and had to press the button corresponding to the location where they thought the rabbit would appear next. There were 15 trials, meaning that the pattern repeated itself twice. So this is the end of my description of our methods. Feel free to ask me any questions about the tasks and results.